MiCA, and it says basically that it applies to natural, legal persons and other undertakings. The keyword here is undertaking. That's coming from case law. And basically, you need as much as possible a parent company or a controlling entity, even if it's a subsidiary, approved here in the EU. You can't have something with a VARA license or a Cayman Islands. I'm getting mad when I hear Cayman Islands at the moment, or Singapore. You need one in every company, in every state. Otherwise, also the likes of Morgan Stanley, JP Morgan would act with their American or British license everywhere. But no, they have a MiFID license in the EU. And they had to do that very shortly after, for instance, Brexit happened. We have another part here that's very interesting, including when part of such activity or services is performed in a decentralized way. So the keyword, decentralized. This regulation doesn't apply to fully decentralized entities. But you exercise control as a human from the first moment, from T0. You press a button. And that's enough, apparently, to trigger this thing. We still wait for case law, of course, but it's coming up. And then you need to understand where's the custody, who actually owns the assets. Are they deployed in a custodial sort of way to the DeFi protocol, the smart contract, or it's still in your wallet and they just read your assets, which I don't think it's really happening. And what's the actually there, the share of controlling. So who can actually screw the little fish? Let me put it that way. So if you have somebody who can overcome thresholds and they can play with the spread especially, then you're not really decentralized, are you? Yeah, basically we have some things here from, for instance, from Italy and also from Spain. And we have a test here that we can use, from Article 3.1 and Recital 63E. And that is borrowing and lending in crypto assets is not within the scope of MiCA, but it may partly form the economic activity of crypto asset transfer services. So to some extent, many DeFi protocols do that, or also staking programs, for instance. That's mostly applicable for staking, and when you are pledging your assets to Binance or something else, and they take the control of your assets, and they can get some yields from proprietary traders and so on, to issue you more yield. That's a collective investment scheme, so it needs another approval. So that's an ETF for us in the EU. So the question is, this begs the question, is there any intersection or not? There's no specific law that I can show it to you, or piece of paper, but we have a lot of argumentation that already reached the court stage. So we have these two judgments, and we have here the decentralized manner argument, whether it's really decentralized, fully decentralized or not. And then you have many regulators with lack of resources to deal with it. So regulators are not legislators. They are law enforcement agencies. They are like police. So you cannot seek real clarity, which is why many people like Coinbase are a bit annoyed with how it goes in the US. People seek clarity and they don't get it. That's not fair. Not at all. I've already explained this once. We have basically here what's under the scope. So we have crypto assets, OCAs, ARTs, EMTs. And then I explained this part about the geographical reach. Basically, MiCA applies extraterritorially. What does that mean? If you are based in Japan and you're providing your services and your website is available to EU residents and their dependents, you need a MiCA license, otherwise you're going to jail. So as soon as you make it available to your target market, you need something. Otherwise, you're acting in the course of business. Categories.
I do need to stop you here.
Yes, but that's
if you have one final statement you'd like everyone to take away, and then maybe we can take one question.
Sure. So basically, you need to be aware that Mika is not all, so you need to take care of ongoing requirements. That's even more important. And then the future of crypto, what's that? Maybe we can talk about this one, about one question about this one. My biggest concern is always geographical reach and whether Mika applies to DeFi platforms and other protocols. Because we have quite some clarity thus far whether something is a hybrid token, a payment token, OCA, whatever else. Basically, we have different taxonomies and they are not homogeneous, not even here in the EU. We have VFA, I work a lot with Malta, and they have only 2 categories, whereas Mika describes 3 categories.
Okay, we do have one quick question, and then we'll need to wrap up.
Yeah, so the question is, as you saw through the recitals with the EC developing this regulation, right, with developing Mika, do you think on the whole there was more of an eye towards conserving and fostering and harnessing this ecosystem in the EU? Was that do you think that was genuinely their goal, or do you think that was just a veil and really and truly they're scared, or really and truly they think this is a scam and let's reduce it?
What's your assumption there? Let me play with it, this one.
Yeah, my assumption is the former. I think that my assumption is the latter one. Sorry. So I think that they're myopic by nature, and that they look at this as outside of traditional banking and doesn't make sense with anything they've seen in their 40, 50 years long careers, and therefore they think it's a niche thing that is most people are just suffering from because of all the constant scams, and therefore they need to stop the hurt that's coming. And I think that they say that they're trying to foster the economy, but they're trying to foster, I think that they're not seeing as too much of the positive. They're seeing what can they stop, and in that they're not thinking big enough in how useful it could be if they let it flourish. They're focused more on the scams and the hurt and the potential money laundering and tax evasion, etc., which means that they say these sort of stated goals of harnessing it, but I'm not convinced.
You shouldn't be convinced by that at all.
I think that's a good note to end on, because we do need to get to the next presentation now, but we can continue this conversation outside if that's all right.
Yes, that's perfect.
Awesome. A round of applause.
But pretty much this is the answer. They want to put everything here because the biggest export product is the US dollar, and this has some potential to disrupt that one. But it's a small market, let's not forget it. Very small.
That's way too much pressure. Oh, okay, perfect. Here we go. Awesome. Thank you all for being here again. And so, without further ado, we have Limone.
Thank you. Good morning, everyone. I don't see your faces because there's light in front of me, but yeah. So thank you for coming here this early morning. I'm Limone from Rome, Italy. I co-founded Urbeit and ETHDam, the leading community for Web3 builders in Italy, and I do a lot of hackathons and building in Web3 for 2 years now. And I'm very passionate about social media protocols, so like decentralized social networks in particular, of course, but I dig a lot into understanding better why, what are like the main issues that we have with centralized solutions like Twitter, Instagram, or any other social that we use in our daily life, and how protocols like Forecaster or Lens are trying to solve these issues. So I already talked a little bit about myself, let's get it started. What are the key components of social networks? So we have the namespace, meaning my username, my display name, whatever, and in this case, like limone.it on Twitter. You have the network, so the social graph that is connecting people and users on the social network with content, follows, likes, whatever. The database, that is the place where we store all the data, and most of the time, I mean, it's a centralized thing. The protocol, it's defining like the rules and how people can actually interact with each other on the network thanks to the social graph as well. The platform is like the website, the user interfaces with which people can interact with each other. And then again, there are also some other rule set like the feed or some forbidden actions, things that you cannot do, otherwise you get like suspended or banned. And all of these, the problem is that with centralized social networks, everything that I mentioned, like these key components, are owned by a single company and single entity, and they can do whatever they want. So think about our friend Elon here. I don't have nothing against him, but it's just Twitter is an example of what can happen in centralized social networks. So think about when Elon got the control of the company, changed the name, and changed a lot of the rule set, not only for users but also for developers. For example, we're also devs here, so we love playing around with APIs and toolkits and new clients or whatever. And Elon Musk here and the Twitter company also changed a lot of like rules, like rate limitings on the APIs or things that you can extract or not from the network. So centralization is definitely like not ideal. Also because as a user, maybe you don't like the new feed, or you don't like the new feature, or maybe you get banned for some weird reasons, and it's not bad. Another thing that happened is that, don't know if you heard about this story, that the X handle was not owned by X, of course. There was a guy owning it, and Twitter claimed the username without asking, of course, like permission to the guy, because it's their database, so they can just change a line in the database, and the handle is now controlled by the X company. And they also send a letter to the user saying that the X handle is now their own property, and they sent him a Tesla for bothering him. Another problem with centralized social networks is that they are walled gardens, meaning that you can't easily escape. Let's say that you don't like Twitter anymore, you don't like the new feed, you don't like the new rules, whatever. You can't simply move into another social network because you have a social graph there, you have your following, your content, your reputation, and it's not easily exported and imported into another social platform. So you simply can't escape, even if you want. That's why I think that we should build and use more open protocols rather than locking ourselves into closed platforms and social networks. Even if open protocols are not immune to centralization. Think about SMTP, the email protocol. Most of us maybe use Gmail or other solutions, while there are, I don't know, Outlook maybe is less used. So somehow we are still centralizing ourselves towards certain services that are more usable maybe, but at least they allow us to choose what to use and what not, and we can still communicate with each other. So if I have a Gmail account, I can send you an email on Proton Mail, let's say. moving further with the spectrum of decentralization, before going to the decentralized example of Farcaster, we have also the Fediverse. Did anyone use Mastodon or know about the ActivityPub protocol here? Yeah, I can't see you, but so Mastodon is one of the main examples of like a federated social network, which is, to me, a trade-off that is not worth it. Because of course, like it has some pros and some cons with respect to centralized examples, but basically this ActivityPub protocol, it's defining like new rules or different rules with which people can interact with each other on these social networks. And the main thing with the Fediverse is that there's a diverse ecosystem of servers, because users can spin up their own instances. You can somehow migrate your account onto like these different servers according to your preference, and individuals and communities control the network, because like each of these servers are not owned by a single company, but there are like multiple instances controlled by me, you, and whoever wants to do it. And these are like the pros. Of course, there are also some cons, because there are still some centralization tendencies, because not everybody is able or want to spin up a new server. So what happened is that most of the people are hanging out onto like 3 or 4 most popular servers. And the problem with that is that you're not giving your data to Twitter, which is a, I don't know, like well-regulated and public and exposed company, but you're giving your data in the hands of some like hobbyists around the world that maybe they are running their server at their own place, they don't have any security measures to protect your data, or maybe they are selling your data to somebody else. You don't know about it. There's also no end-to-end encryption. And there's also communication silos, because sometimes it's difficult to, like these admins can prevent you to communicate with other servers. And yeah, self-hosting is also a challenge. That's why there are not so many servers out there. There are also other protocols which I will not dig like today, but there's Blue Sky, which is an evolution of the ActivityPub protocol, and it was started inside the Twitter company, and now it's a standalone project, and it's following the federated example. Oh great, I have my slides there, I didn't know. Yeah, not anymore. And then there's Nost, so it uses public keys. It's more like a niche and hacker community, not very usable, I'd say, but it has maybe some potential for wider use. Let's go on chain. So the main examples of decentralized social networks running on chain are Lens and Farcaster. I guess you all know about, like, at least like you ever heard about these two players in the ecosystem. Farcaster is a sufficient decentralized social network, while Lens got into a full decentralization approach. They share something similar, but they're also like very different in the way they develop their own ecosystem. Starting from Lens, again, everything on Lens is on chain, it's running on Polygon, and it also has an L3 optimistic technology to store content that is called Momoka. Everything is an NFT, so your profile is an NFT. Every time you follow somebody or like something, you're minting an NFT. And that's why it's not really scalable, because you need like to pay gas fees, of course, and you cannot even delete whatever you post or create on the network. It's cool, but it's cool because you have like composability and monetization modules. You can extend your profile and easily like create new type of NFTs that you can plug into your client or experience to make things more interoperable and customizable. And of course, like it's fully decentralized, so because it's running, fully decentralized. It's running on Polygon, so it's following their consensus. About Farcaster, Farcaster is sufficiently decentralized. Again, this means that not everything is on chain. The only thing that is running on chain on Farcaster is the identity layer, meaning that your username and your unique identifier in the network is stored on a smart contract on Optimism. Everything else is running on an off-chain peer-to-peer network. So it's getting this network, it's not getting synchronized with the standard consensus that we've seen in blockchain, but it's just synchronizing themselves with eventual consistency. Usernames are readable. It's very similar like to Twitter in some ways. The protocol is built like with small text like I think the maximum of a cast, which is the tweet, is like 320 characters. So it's very similar to Twitter. But the most interesting thing about Farcaster to me is the sufficient decentralization definition. So a social network achieves sufficient decentralization if two users can find each other and communicate even if the rest of the network wants to prevent it. And that's what we care about, right? And how we can achieve it. So to achieve this sufficient decentralization, users should always be able to claim unique usernames, meaning that if I'm limone.it, nobody else can own my username, and I'm the only one able to post with that username to the network. And the last thing that I want to have as a property is that I can always read messages from any valid usernames in the network. So as long as these three properties hold, we have a sufficient decentralized social network, and we are sure that we can always communicate with each other, even if somebody wants to prevent it. But how does it work? I mean, I already mentioned like the identity layer is running on chain on Optimism, so you can register a new ID with your public and private key and storing a new record in the registry. So you have your address associated with an ID and a username. Usernames are also compatible with ENS, so you can use your ENS as a username on Farcaster. And every message that you publish to the network is not going on chain, again, is going to a distributed network, peer-to-peer network. And you're authenticating each message with your signature, so that apps can check who was the real author of a content, because you're signing every message you're saying. And messages on Farcaster are like new casts, new posts, follows, likes. All the interaction that are happening are messages sent to this network that is constantly getting synchronized. The nodes of the network are called hubs, and people are running hubs. I think there are like 400 hubs right now in the Farcaster ecosystem, and they are like synchronizing the state of the network constantly and allow people to create new client apps on their data. So there are already even some services that allow you to easily spin up an app and access an API to start building in the Farcaster ecosystem. Yeah, I already talked about the IDs and names. I mean, human readable IDs are like canonical user identifiers, incremental numbers. I think there are like 300,000 users now on Farcaster, and they are now like compatible with the ENS. Again, on Farcaster, on-chain, Farcaster is not like Twitter on the blockchain. Farcaster has on-chain only things that are needed for the sufficient decentralization things. And the blockchain, like why they decided like to do it like this, because the blockchain is a poor storage mechanism. First of all, because it's immutable, and for a social network, there's no point in having immutable content. And of course, it's also bandwidth limited because, like I was mentioning on Lens, whenever you want to do something, you need to mint or send a transaction. And that's why I think like this approach is much healthier, because it's much more scalable. And I mean, it's a social network. It's not a governance system or any other like maybe payment system where you want full transparency and decentralization. It's enough. How the Farcaster stack work? So again, I've mentioned here we have the identity layer on the on-chain Optimism, and the hubs is like the decentralized, is the distributed peer-to-peer network synchronizing the state for the network. And we have the application layer here where you can build like new APIs interacting with the apps, and these APIs can interact of course with new client that you can build on top of it. So there are already 10, 20 clients, both web and mobile, native, and many like open source stuff. So it's easy, very easy to start building in this ecosystem. This is a simplified version. So accounts on Optimism, username on ENS. The data APIs is on Hubble. Hubble is an open source library to spin up a hub. And then you have the application layer here. Like we have WordCast, which is the main client. Then you have Jam, Yoop, and Supercast is another one getting some traction lately. And yeah, again, why the blockchain? Because blockchain, so why it's better like to build decentralized social networks on blockchain, because blockchains are distributed and ownerless, so no single actor can modify or control a smart contract, meaning that your username is held and owned only by you, and nobody can revoke that from you. And blockchains are also permissionless and public, so anybody can access their state, build software on top of it without asking permission to anybody. So you don't need an API key. I was mentioning like Twitter, rate limitation, and rule changing on Farcaster, but also on Lens. You don't need to care about people changing your rules. So as a developer, you can build and feel like safe that nobody's changing stuff. So again, why decentralized social? Just to recap a little bit, account ownership, meaning that you are the only owner of your account, nobody can control it. Data portability, because there's no need for migrations, like we were mentioning for Twitter or Mastodon, for example, because everything is running on a shared layer. So if both on Lens, on Farcaster, if I want to move between clients, I can still plug in my own identity, social graph, content, whatever, because I'm still logging in with the same wallet or public-private key pair. Permissionless innovation, because you can build services on top of these protocols without asking permission to anybody. Censorship, resistance, and moderation. It's something that I didn't touch in the talk, but for both like Lens and Farcaster, protocols are open, so everybody can publish stuff. Of course, like people can also publish like bad stuff. And nobody can censor them at the protocol level, but what happens is that the clients can, of course, like moderate content at their own purposes in the application layer. So let's say that I have a Farcaster client where I want people to only talk about cats. If there's somebody talking about dogs, I can moderate them, but I can prevent them to still publish to the network and to the protocol, so that if somebody else wants to build a dog-based client, they can still build it and read dog-based content. And that's it. Thank you. Like, these are my handles if you want like to reach out on Twitter or Farcaster. And if you have any question, happy to answer them.
Awesome. Thank you so much. Can we have the lights on so that we can at least see? Do we have any questions for Limone about social or how awesome his hat is?
How can we incentivize people to participate in positive ways instead of trying to manipulate social media like distributed ways, like through using bots or through like spamming things? Like in crypto in particular, I think communities really struggle because there's so many people shilling random projects, and it's really hard to filter through all of what people are trying to promote, all these projects.
Yeah. This has been an issue lately because, like, especially on Farcaster, a lot of like spam get into the network because the social network was growing. So of course, like people looking for airdrops or other stuff started joining Farcaster, registering new accounts, and spam has been a problem. Of course, it's not a problem as big as you have maybe on Twitter, where you can simply like register an account. On Farcaster, of course, it's still a niche, so there are less people than Twitter, so still less noise. And the other thing that is preventing like spam to grow after a certain threshold is that to register an account on both like Lens and Farcaster, you need to run a transaction, so you need also to spend money. For example, on Farcaster, it costs $5 to create an account because you need to pay for the storage that you're using. So this is already somehow preventing most of the spam. But still, there are bots in the network, and there's a lot of work being done at the client side of things to create new user experiences or new algorithms that prevent you from reading spammy messages. So it's not, again, if you can't prevent bots at the protocol level, because that would be even being able to censor content at the protocol level. We don't want that, but you can still moderate and read content however you prefer on the client side of things. So then I hope that this answer. So it's about people creating applications, finding their best way, and maybe even open sourcing them to avoid spammy content.
Awesome, thank you. Did we have one more question? No? Awesome. Well, thank you so much again.
Thank you.
working. Fair enough. Fair.
All right, we're going to go ahead and kick off our next amazing piece of programming with David.
Hello, hello. Hello, everyone. Thank you for coming to my talk, nice and early. So today I'll be talking about deciphering DAOs, insights from off-chain dynamics. So I assume some of you, all of you know what DAOs are generally. But what we'll be talking about today, and I think the screen switched off, so maybe if we can get the screens back on. Yep, okay. So we'll talk about DAOs, protocols, and communities, and we use them interchangeably throughout this talk. We'll also analyze some qualitative data as well as a little bit of quantitative data. We'll try to create some insights from this data and then also enable you yourselves to draw your own insights and conclusions from this data. So a little bit about myself. I'm David, founder of X23.ai. It's a startup. And the screen keeps switching on and off. I don't know if that's my issue or not. Maybe. Could be. All right. But so previously I was on the Aave Genesis team back in 2020. Then also in 2015 I was ex-Coinbase, working in and out of DAOs for a few years now. Okay. So the thing about DAOs is that a lot of people have heard about it, and some people work for DAOs, but a lot of people don't actually know what DAOs are. And the thing is, there's no real like actual definition of exactly what DAOs are. So they're, as most of you probably know, is like they're meant to stand for decentralized, but a lot of them are not decentralized. They're meant to be autonomous, but a lot of them aren't autonomous. And the final word, organization. They're meant to be organized, but they're not quite organized either. So what actually are DAOs? So a lot of DAOs look like this, where they're essentially a group of friends fighting with each other and sometimes agreeing, most of the time just disagreeing with each other. Thank you for the tech help. I appreciate it. And with lots of spectators watching the fights happen online. At other times, no problem, we'll wait for this to come back on. But at other times, DAOs can just be a bunch of people that are just hopping on the train, hoping for an airdrop of some sort, or just, watching. So it sort of looks a bit like this picture sometimes. And especially these days with the whole thing about airdrop farming, a lot of people are doing that. Or worse, I think there's something wrong with my computer. Sorry, guys. Or worse, they're like echo chambers. I don't know what's going on. Oh. Yeah. Yep. Yeah, we can. Okay. Yeah. How do we do that? What do I do?
You send your file to our email.
Yep.
That's technically.
All right. Actually, it's a Google. Let's just share it.
Oh yeah, you can share it to us.
This is if it works. Sorry guys for the tech issues. We can just check it in.
Thanks, man.
Seems like maybe the tech also had a late night last night.
Sure. Yeah.
There we go.
Yep.
So just send there. Is that
Yep.
right?
Yeah. Just send that.
So I'll load that onto one of our computers.
Yep.
We can just restart.
All right. Cool. All good. All right. So I guess we're gonna restart. Do you want me to start from the beginning as well? All right. All right. Sorry, guys. Sorry for the chaos. We're gonna redo this. Just forget everything that I said. We're gonna go back from the beginning for the recordings, for the internet peoples. But anyway, while we're waiting, who here is like participating in DAOs? Put your hand up. Yeah. What DAO are you part of?
Lots. Pizza DAO, but also I'm kind of working on my own. Yeah, I have a website. But yeah.
Sweet. Yep. Pizza DAO. Anyone else? You said yep.
Angel Squad DAO.
Angel Squad.
Yeah. Angel Squad Venture DAO.
Okay. Cool. What do you guys do there? Angel deals, I guess.
Yeah, mostly investing.
Okay. Cool. Very cool. Yeah. Any others? Any other DAOs? DAOs being, either they don't have to be decentralized or autonomous or organized. Wall Street Bets. Yep. True. That's like a community. Yep. Community DAO. Wall Street Bets. Yeah. Martin.
Working on Project Copernicus DAO.
Yep. Very good. That's definitely a DAO. So I guess DAOs can be really anything, because no one's really following the whole definition of a DAO. But generally, I'd define them as communities or loose groups of internet friends. How are we looking with the slides?
Do you mind if I share it to one of our Google?
Yeah. Do what you need to do.
Is there anything you would say is crucial or like a requirement of a DAO, like a minimum number of people, or does it have to be on chain?
I think it just depends who you're talking to. It's like blockchains or tokens, right? How do you define tokens? How do you define blockchains? Depends who you talk to. How do you define crypto? Right? Some people are like I don't know. Some people don't like Ethereum for whatever reason. Some people don't like Solana for whatever reasons. Depends on where you stand. So I think the same thing with DAOs is it really depends. Yeah, like I was saying, like Wall Street Bets, for some people that could be seen as a DAO or a community, a loosely organized community. Yeah. What do you think it is, Stelling?
I tend to agree with you. I was having a conversation recently with someone who felt that it has to be on chain somehow, or else there's no reason for it to be called a DAO. That otherwise it's just a community. So as a writer, I find like these kinds of discussions around words and verbiage and vocabulary very important and very interesting. But yeah, I mean,
True.
I don't know if we need to be so rigid in our definitions.
Yeah, I mean, some DAOs, like, it could be a DAO where you just have like a multi-sig, like on chain, but you're not doing anything else on chain. So I don't know.
I think that was something I was very interested in was, or feeling like I wasn't allowed to have a multi-sig with friends unless we were called a DAO and that we had like some sort of mandate or like vision. But that we could just call ourselves a DAO or just have a multi-sig.
Yep, question?
Surely if you just have a multi-sig, you do have some sort of mandate for, surely, like, if you have a the question, why can't I have a multi-sig with my friends without some sort of mandate or some sort of vision? Like, the multi-sig might have at least something like, okay, somebody's gonna cover this restaurant cost. Like, we're gonna go for this meal, and then we're eventually gonna pay for it. Our mandate is this restaurant meal, and our rules are people will pay in accordance with these terms, even if they're not clearly defined. Like the multi-sig needs some structuring around it. Otherwise, why did you use the technology? And
Yeah,
I think,
sure.
Like for me, I think DAOs, to just push back a little bit on. Sorry, I was at another talk.
Yeah, go for
But to push back a little bit on what, like, the terming and it's too rigid, etc. But it also can lose all meaning if we don't put some constraints around it. Because so decentralized, it becomes like, okay, fine, why can't I call this conversation in this room a DAO as well? So it's I think it makes sense so that we can know what we're talking about.
True. I mean, that's the exact point. So some people, you think it should be like a bit more rigid. Other people, like, let's say Wall Street Bets, is that a DAO? Some people say absolutely not. Some people might say, maybe if I should have a multi-sig to Wall Street Bets. But who has access to that multi-sig? All right. Anyway, good conversation. We can go into questions a bit later. So now we're going to restart our talk. So just forget what I said, and it's going to sound like repetitive, but, we've got to do it for the stream. Okay, so welcome, everybody. Thank you for coming to my talk. So today we're going to be talking about decentralized DAOs, insights from off-chain dynamics. So for this talk, So for this talk, we'll talk about DAOs, protocols, communities in Web3, and we'll use them interchangeably. And then we'll analyze some qualitative data as well as quantitative data. We'll try to create some insights from that data and enable you to draw your own insights eventually. Okay, so a little bit about me. I'm David, founder of x23.ai. I'll talk a bit about that a bit later. Previously, I was at Aave Genesis team back in 2020 and also with Coinbase in 2015. I've also been a part of a few DAOs, both like venture angel DAOs, but also I'm a reviewer on the Aave Grants DAO as well. So, talking about definitions of DAOs and what exactly are DAOs. So a lot of people have heard about them, but there's no real, I guess, agreement, even in this room, on what exactly are DAOs. So for those that don't know, DAOs stand for decentralized, but most of the time they're not decentralized. Autonomous, a lot of times they're not autonomous. Or organized, but a lot of times they're definitely not organized. And it can be a little bit like this picture, where it's just a bunch of people arguing about, like very passionately arguing about certain topics, and then a lot of their friends are either watching or participating. But that's a good DAO if you have like high participation rate, right? Because that's sort of what you want. Whereas sometimes other DAOs can be just like a bunch of people hopping on the train, either airdrop farming, and they're just speculators, or they're just watching. And that's generally what you don't want, depending on I guess, the size of the DAO, especially if they're just, looking for airdrops or to be leeches to your organization. And at worst, they're just echo chambers in that, you make a proposal and everyone will just agree with you. So that's sort of what we don't want. So our goal for this talk is that how do we differentiate between these, let's call them DAOs, but when I say DAOs, I mean communities and sort of online communities, organizations. How do we differentiate the different types? So let's say the active or healthy DAOs. How do we define that? Well, we need to look into the data, right? But what sort of data should we look into? So there's price data, right? But price data doesn't really indicate anything because traders will be trading, and you can see from these sort of dead projects that they still have a lot of market value. So price data doesn't really mean much in terms of the health of DAOs. We can look at social media activity, but as you know, there's like bots, and bots will be spamming. You can see all the hashtags here. So we can't rely on social media activity either. Voting activity is a bit better. So a lot of on-chain DAOs that have voting activity. So you can see here, there's Uniswap. There's about nearly 400,000 holders. And of those holders that actually vote, there's about more than 40,000 voters. So that's about 10% of holders. And that's pretty good, right? So that indicates a relatively healthy DAO that's participating, that has high participation rate. And then the other piece of data that could be useful is forum activity. So the good thing about forum activity, it's quite qualitative, but also we get pseudo identities. So we can see who are the contributors to the DAO, right? We're not just like faceless people, and we can see like what's important topics and things like that that's happening in the DAOs. So what sort of data should we look at? We should look at qualitative data, that's forum data, quantitative data, votes, also historic data over time so we can compare, and then across Web3 so we can compare all these different DAOs so we can see what's healthy and what's not. Okay, so X23, that's my startup. So what do? We crunch the data. Essentially, we uncover what's happening across Web3 by aggregating, condensing, and then prioritizing all this data to help you make better decisions. So we've indexed about nearly 30 protocols now, or 30 DAOs, across forum discussions, snapshots, GitHub pull requests, GitHub repositories. Eventually, will be on-chain data and also like social data. We have about more than 50,000 pieces of content now that we've indexed. And then we created this product called Community Rankings. So it's sort of like, let's say, DeFi Llama or CoinGecko, but for the health of communities. So I have rankings, all time, weekly, and things like that. And so I'll use that as a basis for this talk to dive into the data. So what can we learn from voting and forum activity? A few things, right? So I'll go through like categories, what is being talked about, active topics, like what are there more discussions? Is it stagnating? Is it growing? Is it same or less? Who are the contributors, right? Who's contributing what percentage? Is it just one person posting everything? Or like, lots of people posting? And voting dynamics. So are there dissenting opinions, or is it just an echo chamber? Are things passing super easily, or is there a lot of friction in these proposals passing? And I'll explain what those means and the insights we can get from them. Yeah? All right, so categories. If we look at categories of all time, we can see that categories meaning like tags. So what we did with this data, we crunched all this data, then we pulled out the category tags of like, okay, what are people actually talking about on these forums? So number one here, you can see this is for all time. So MakerDAO is the most active DAO. Then it goes Ethereum, Aave, Balancer, ENS, Gitcoin. So these are the types of categories that have been talked about all time, right? So MakerDAO stablecoin, that makes sense because they're a stablecoin. Ethereum, developer tooling, that makes sense. It's a developer tool. Aave, lending, yep, that's pretty good. Balancer, DeFi, Balancer's a AMM, but they don't really talk about the AMM part because they're a bit more than that. All right, so they're talking about DeFi, which is interesting. ENS, identity, which makes sense, and then Gitcoin, grants and funding. So that's interesting. We can get insights on what's been talked about all the time. But if we also compare all time with, let's say, weekly, we can see how it changes, right? So this was, I think 2 weeks ago, actually. We can see that the tags changed. So there was a new one in MakerDAO, which was vote. So that means for that week, an important tag came up, which was there was an important vote that was happening. With Ethereum for that week, there was less talk about developer tooling and more talk about controversial things, because there's a controversial EIP that was submitted and talked about. For Aave, there was the same categories. You can make your own insights from that. I think it's that the Aave community really talks about the same things. They're quite focused. Balancer community talked about funding, and I think that was in regards to providing funding to projects to build on top of Balancer. ENS, they talked less about events and more about developer tooling, because ENS started to, I guess, pivot in this direction of, trying to bring on more developers to build upon the ENS protocol. And then Gitcoin is interesting that they added social impact. So if you've been keeping up to date, you can see that Gitcoin is like having this pivot into social impact. So those are some interesting insights we can get from just looking at the categories and how they evolve over time. Right? If we look at the topic discussions over time, in the same way, we can see that we're ranking them from the activity. So how many topics were created. And you can see for all time, MakerDAO was number 1. But then for weekly, MakerDAO went to number 4. Right? But then you see Ethereum and Aave remained both 2 and 3. And then we had Optimism come up. Right? So it's interesting to see, like, okay, MakerDAO from all time, MakerDAO has the most topics. But in the last week, it's still active, but it went down quite a bit. And what caused that drop in rankings? So if we graph the activity over time, we can see that, hey, there's a peak, and then now it's sort of going down. So what does that mean? Does that mean like MakerDAO is stagnating as a community? Does that mean like less people contributing or not? Well, we don't know until we compare to other communities. So what we can do is we can look at, let's say, Aave. You can see that there's a spike, but it's trending up. If we look at Ethereum, we can see Ethereum, it's trending up. And if we overlay all of them on top of each other, we can see that from this graph, one interpretation would be that MakerDAO is, the discussions at least, are stagnating, or that they're going more offline, right? Because their MakerDAO is like sort of restructuring its entire community, and they have all these secret projects, so maybe things are being less publicly collaborative, whereas both Ethereum and Aave are increasing or trending up. So another one we can look at is Optimism, which sort of burst onto the charts at number 5. We can look at the topics over time, but it's interesting if we compare Optimism topics over time, and they are the yellow line here. So you can see that sort of they burst onto the scene, and they're sort of pretty consistent, or almost the same as like Aave and Ethereum. So this indicates to me this is what a healthy community looks like. Like there's tons of activity. Ethereum and Aave took a long time to reach that sort of level of activity, and Aave sort of and Optimism burst on the scene, and they're quite active. So that's interesting, especially comparative to what's happening at MakerDAO. All right, so we can also look at the authors and contributors. Right, so if we look at the author-contributor rankings, that's the middle one here. We won't go through all of them, but we can focus on just 3 of the protocols: Aave, Optimism, and the graph. So we can see that. So basically what we do with the data is that we count how many contributors made topics, and then we can see who made the most topics of that community. So of Aave, Chaos Labs made 129 posts out of 1,500 posts. So that's about 8.4% of the topics created over all time was by Chaos Labs. Right, but we don't actually know what that means. There's no insights from that until we compare with other communities. So if we compare with Optimism, the system account, which is their official account, they did about 12% of the posts. And then with the graph, there's Oliver, who did 4.76% of the posts. So what does that mean? Does that mean that the graph is more decentralized or more healthy than Aave? Because Oliver's making sort of half he's the top poster in the graph, but he's making half the post that Chaos Labs is making. We could make that insight that maybe the graph is more decentralized because more people are contributing to discussions. But we also have this other column here, which is the voting trends. So if we compare the voting trends with the contributors, it becomes quite interesting because we can see that Aave is quite controversial. And the way we measure how controversial the voting trends are is essentially how the difference between voting, like how people vote in proposals. Whereas the graph, it's quite unanimous, right? So what does that mean exactly? What are some specific examples? Well, here's an Aave proposal. We can see here that it's like nearly 50% voted yes and nearly 40% voted no. Right, so that's a pretty split community. For this other controversial proposal, is also 55% and 45%. Right, so that's pretty split. Now, if we compare that to the graph proposals, what does the graph look like? Well, it's like 99.72% voted yes. Right, and another proposal, they have another 99.93%. Right, so it's quite unanimous when you compare the graph and Aave. So what does that mean? Like, which is more decentralized? You know, which has more broad community involvement? Which community is more aligned? What's healthier for community protocol DAO? Like, I don't mean to like dive too much into the graph. I know, like, from a technical perspective, they're quite decentralized, but from a community perspective, it looks like they're not as decentralized. They're quite unanimous, right? Whether what's healthy or what's not, it probably depends on what you're trying to build and stuff. I think it's interesting insights for you to draw, anyway. But of course, I have to mention that authors and contributors can fluctuate over time, as well as the voting trends. So you can see this is the monthly voting trends. It was controversial, and then, Arbitrum was quite controversial, but Aave wasn't as controversial. It was just contentious, right? So if we change the, like, between week to week or month to month, or how many proposals are being submitted, it can become more controversial or less controversial. But it's always interesting to look over time. Okay, so going back to our goal of how do we determine or differentiate between these different DAOs, we look at the data and the qualitative data that I mentioned as well as quantitative data. The disclaimer here is that different DAOs have different cultures, as I mentioned. What works for one DAO may not work for the others. You know, MakerDAO has a specific culture, the Graph has a specific culture, and Aave has a specific culture. It really depends what you want to align with. If you want to align with something that has a lot of different contributors, you can sort of see what DAO sort of fosters that. Or if you want something that has like a very strong alignment with the founding team, you know, maybe something like the Graph or other DAOs would be more similar. So the community rankings, it's like a free app that you can just go on the website. Yeah, you can check it out and make your own insights from that if you want. That's the end of my talk. So I think we can grab some questions now if you guys have. Thanks for having me.
Awesome. Thank you so much. And I know we did a little bit of questions earlier, but we still have a bit of time. If we can have the lights up so we can see everyone's beautiful faces. Lovely, lovely. Question?
Thank you. Thanks for your talk. Are you looking at the repartition of the voting power? Because typically, like, you know, if 5 people can vote for like 80% of the DAO, might, you know, leads to some result.
Not yet. But what we do is we're looking at the volume of votes. So we can see, you know, if someone's delegated a lot of votes to someone else, we can see that. That's why we get like 50. If it's a 50-50 result, that means it's quite controversial, right? Yeah.
Hi, thanks for the talk. It was great. So I think the data that you have is fantastic. It's really interesting to look at. Just to push back maybe a bit on the conclusions. Like recently, I've talked to many people and kind of come to the conclusion that often increase in activity is actually not a good sign for a DAO. So it very much depends. I think I'll qualify that by what the DAO wants to achieve. But you know, more activity means that often it becomes more confusing for outsiders, and you get these kind of inside cabals that basically make the decision. It's very hard for anyone from the outside to get through the noise, you know, get what's going on, and especially for DeFi DAOs, I think that's the case where probably you don't want many votes. You just want to vote on very fundamental things to get the broader community involved. But you kind of want expert decision making largely. Did you have a view on that, or would you agree, disagree?
It's a very good point.
Interested in your perspective.
I think overall I strongly agree. around there's like too much activity and it becomes cumbersome, and that's why I created like X23, a little shield of X23.ai. So we help solve information overload, right? So essentially we use AI, large language models, to essentially condense all that information to make it more easily accessible. So that's why we can do this sort of data. So it's like even if a community is posting like I agree, and you have all this spam content, we can filter that out. So we can actually just draw out the actual proper like actual real discussions, right? So that's what we're measuring here. So I disagree that more activity is bad for the health of the community, but I agree that more activity becomes harder for people to get onboarded to the DAOs, and that's a problem we're trying to solve with X23, is to make it less, overwhelming. And then you can do we have a search interface as well. So if you're only interested of like grants for Gitcoin, you can search for that. Or if you're only interested in, I don't know, risk parameters at Aave, we can just draw that information out. Yeah.
All right, we got time for one more question.
Okay, yeah, great talk, thanks. Being it's such a new field, so there's no scientific balance yet, probably. So I'm curious, are you aware of scientists investigating DAOs and getting to definitions? And are you planning to integrate those definitions or into your protocol? Because on the technical, social side, there's so much to discover, and it seems that you're generating it now from the data, but on the definition side, I would say there's also a lot to gain.
Yeah, I mean, like we had in the early discussion, around definitions, I think I'm not really from academia, and I think academia and regulators are always lagging, for us in this room that are on the bleeding edge. But I do have some academics that use our data in their PhD thesis and things like that. So I think over the next year or two, you will start seeing more academic definitions, because they're aware of this. So they will make their definitions, but there's no central regulated body that says this is what DAOs are meant to be and things like that. But yeah, I encourage academics to come in and study this stuff. There's a lot of interesting things, a lot of interesting insights they can pull out. I think there's new organizational mechanisms that can be applied to traditional companies as well, around participation. But yeah, good
Awesome.
question.
Thank you so much, David. And if you have further questions, please ask him outside, because I'm sure he'd be more than happy to talk to you. Cool.
Thank you, everyone.
Thank you. Ooh, the drama. The lights going down, but then you can't see anyone. All right, thank you everyone for being here. Next up we have Chris.
All right, thank you guys. I can give you a little introduction of me. My name's Chris Pacia. I've probably been around in this space for quite a while now. It feels like I think I got into Bitcoin like 2011. Early on I worked on OpenBazaar. I was lead developer for OpenBazaar. I don't know if you guys remember that project. I know Amir mentioned it last night on stage. It's a little bit of a throwback. And then I was also pretty kind of heavily involved in the scaling wars on the wrong side of that back in like 2014 through 17. And I was one of the handful of developers who kind of got Bitcoin Cash off the ground. So I want to talk about a project I've been working on for a couple years at this point called ETHDam. It's a new cryptocurrency. The way I'm kind of thinking of it is it's sort of like, you know, if we had to design Bitcoin or really any cryptocurrency from the ground up using 2024 technology, what would that look like? And so I'm kind of going to walk you through what that looks like in ETHDam and you know, why I think that this is at least interesting to say the least. So, you know, ever since, you know, I got into Bitcoin, there were probably, we all knew there were shortcomings early on, right? And I would say at least these, you could probably add to this list. I would say these are at least the big ones. Extensibility. You know, if I were designing Bitcoin in 2009, I wouldn't have thought to add a scripting language at all. I think that was pretty amazing that Satoshi had the foresight to do that. But you know, of course, unfortunately, it wasn't as flexible as you would like it to be. There wasn't like a whole lot that you could do with it. You know, privacy, of course, being a big one. With all of our transactions being public, then we have the the zero conf issue with the transactions not really being secure, and then even after they receive a confirmation, you know, you have to wait to receive a certain level of confidence before you can really accept it, and then of course we have the scalability problem. So, you know, extensibility was sort of the first nut to be cracked. With, you know, Ethereum came out, you know, not that long after. And so, you know, that's, you know, pretty much a solved problem. Privacy, I'd say I have a little shoulder shrug here. You know, we had coins early on, some coins incorporating, like mixing into the protocol. In fact, you know, I worked, when we worked on Bitcoin Cash, we worked on some really advanced mixing protocols like Cash Shuffle and Cash Fusion and stuff like this. You have Monero. Added like probabilistic privacy into it, and then of course Zcash kind of did it what I consider sort of be the right way by using ZK snarks to kind of, you know, fully encrypt all the transactions. But Zcash and most other cryptocurrencies to follow that have had that type of privacy historically have not been able to extend that to smart contracts or any kind of scripting language or anything like this. So, you know, the privacy is usually just for basic transfers and nothing else. And then the speed of the transactions, we've gotten better at that with a lot of proof of stake coins are somewhat fast to finalization, although depending on your use case, like if you're trying to buy something in person, you know, it still might not be sufficient. And then you have, I'm kind of a bit of a fan of the Avalanche consensus algorithm. We'll talk about how we use that in ETHDam here in a little bit. But, you know, I'd say Avalanche is probably the one cryptocurrency that has that level of like almost instant finalization to it. But there's trade-offs with that. And, you know, so I have the shoulder shrug here because it's not fully solved in terms of like, can you achieve that level of fast finalization without having to have any of the negatives or any of the drawbacks to it. And then, you know, scalability, we're still here. So this is kind of the landscape of at least kind of where I see cryptocurrency has been. And so, I mean, we're in 2024, Bitcoin came out in 2009, and we still don't have any cryptocurrencies at all that are able to do all of these things, okay? Which is pretty amazing, because these were the things that we kind of all identified very early on we could improve upon, and we're kind of still not there, at least not there in terms of you know, it all being done in a single cryptocurrency. So I want to talk a bit here about primarily the privacy and extensibility, kind of how we're going to do sort of smart contracts and scripting in a in zero knowledge in Ilium, and we're going to give you a kind of a little bit of an overview. Hopefully you guys will be able to follow along. So ZK snarks, hopefully you know what this is. This is a kind of a programmatic zero knowledge proof where we're essentially going to create a function, and the prover and verifier are going to have prior agreement about what that function is. Could be anything we want it to be. And then the prover is going to prove that he knows some inputs to that function that make the function produce a certain output without revealing what those inputs are. Okay, the function in our example here would be foobar. And if the interface was just this simple, it would be really nice and easy to use ZK snarks, but unfortunately it isn't. Yeah. So we have issues with ZK snarks that have really kind of prevented us, at least up until very, very recently, from kind of deploying them very widely. So when you're writing these functions, like that foobar in the previous example, you're not writing in Boolean logic like you would in a normal computer program. Instead, you're having to write in arithmetic logic, in basically trying to formulate your statements in terms of like, you know, mathematical expressions, which is kind of like worse than trying to program in assembly, okay? Like much, much worse. We have an issue with loops. So normally in normal programming, you have a loop. You can break out of that loop at any time. You don't have to, the loop doesn't have to continue going, you know, after you're done with your computation. But in ZK snarks, you can't really break out of a loop. So what you need to do is, you know, let's say you're doing something like trying to verify a Merkle proof. You might need to, you know, sometimes that proof might be very small if your set is very small, and then other times it might be very big if your set's very big. But in the cases where your set is very small, you can't just skip all the other iterations of the loop that you don't need. Instead, you have to calculate what is the maximum number of loops that I might need. What's the maximum size of my set, for example? Then every single time you need to do that maximum number of loops. So your computation can blow out pretty quickly. Along those same lines, if you have if-else statements, you have to execute both sides of the block, right? So if one side is a very small amount of computation and the other one's a large amount of computation, you're going to be executing both of them, and you're going to have to bear that expensive cost. So it's definitely not like normal programming, and it kind of limits what we can do with it. So in recent years, and this is like very recent stuff, like the last year or 2 years, people have been putting in a lot of effort to try to make systems where we can use ZK snarks more like regular programming. And so the one that I use here in Ilium that I'm going to talk about is called Lurk. Lurk is a Turing-complete programming language. It was developed by Protocol Labs. I don't know if you guys, they're the same ones who make IPFS and Filecoin. The lead developer for Lurk, his name's Chimed Kurtzang, I believe, if I pronounced that right. And he wrote the ZK snark implementation for Filecoin, which sounds like it was a nightmare to create. And so he kind of took those lessons that he learned from writing that in Filecoin and applied it to Lurk. So the basic idea here, what we're looking to do, is we have in computer science, we have this concept of like a universal Turing machine, something that can kind of execute any sort of computation that we want. What we would kind of like to have is a universal circuit where we can create a proof for any kind of computation that we want. And so part of the solution to this has been with some advances in cryptography in recent years with the recursive snarks and the incrementally verifiable computation. The basic idea here is we're going to have a circuit that we're able to kind of sort of step through our program and go through that circuit multiple times in order to execute our program. So it then does sort of beg the question, like, what should that circuit look like? Because we do have still have these underlying issues with the performance of the ZK snarks and the optimizations. So we want our circuit to be kind of as minimalist as we can make it, for performance reasons. So what is kind of the minimalist type circuit that we can come up with for this like universal circuit concept? Then we have this real big throwback to 1960 here, recursive functions of symbolic expressions and their computation by machine by McCarthy at MIT, where he's introducing Lisp, right, the Lisp programming language. So Lisp is a very, very minimalist programming language that it creates you have a CEK machine where basically you take an input and you have a very minimal state transition. It produces an output, and you can kind of recursively step through your program that way until you can execute the full program. And so something like this is basically what Lurk is implementing inside the circuit as kind of a very minimalist form of a programming language. So I asked ChatGPT to give me a diagram for a CEK machine, and this is what it came up with, which is not even remotely close. But I mean, you can think of it as we're going to have a program, we're going to break our program up into multiple steps. And for each step, you have the input into our circuit. We perform some computation. We get an output. That output then becomes the input to the next iteration of the circuit. So when we create a program, this is a little program calculating a Fibonacci sequence. We can, in this example, we've got 89 iterations through the circuit. So we're going to step through our program, iterate through our program this way, and at the end result, we're going to get a single succinct ZK snark proof that proves the correct output, that the inputs that we have to this program produce a particular output. The nice thing about this is we're back to using Boolean logic again. We're not using arithmetic logic. Loops work the way you think they would. If you can break out of a loop, you don't have to calculate what is the maximum number of loops that I need to make. If statements work like you think they would, if you have expensive computation, you can just skip that. In the else block, or whatever, you only execute one side of that block rather than all of them. So basically, we're back to normal computation again. So how do we use Lurk and Ilium? All transactions have a ZK snark proof attached to it. The proof, this is a UTXO model, by the way. We prove that the inputs that we're spending in our transaction exist in the set of all outputs in the chain. We prove that the inputs have not been previously spent. We prove that the output amounts do not exceed the input amounts. And we prove that the spender is authorized to spend the coins. And we do all of this in zero knowledge. So basically what this is we've just recreated Zcash, essentially, right? This is very similar to how Zcash works, albeit we're using a little different cryptography under the hood, but same concept. But can we go a little further? So in Lurk, we have there's this kind of built-in concept called functional commitments, where any expression, you can basically get a hash of it for all intents and purposes. So here we've got a function, f of x. We can call that commit function to get the hash of it. And then later on, we can open it up and execute that function just by calling this open command. And in this case, we have an output of 122, and we could prove that we know some input, which is the number 5 in this case, that makes the output, that produces that particular output without revealing our input. So with this concept of functional commitments, if you think about it, I don't know if your brain goes the same place that mine does, but it reminds me quite a bit of the pay-to-script hash in Bitcoin. So in Bitcoin, some address types have this, their pay-to-script hash address, where you create a script in Bitcoin and you take the hash of it. This hash becomes your payment address, essentially. So your payment address that you send coins to is just the serialization of this hash. And then when you want to spend the coins in Bitcoin, the spender has to provide this script as part of the transaction. And the full nodes on the network will verify that the script the hash of that script matches the hash that you committed to in your address. If it doesn't, it's an invalid transaction. So basically, we do the exact same thing in ETHDam, where all addresses are pay-to-script hash addresses, where the script hash in this case is a lurk functional commitment, where the user is committing to any kind of custom locking script, if you will. Unlike Bitcoin, however, this is a Turing-complete language, and you can do any kind of computation with it that you want. And just like with Bitcoin, when you go to spend your transaction, the spender has to provide the script, and then we verify that the hash of the script matches the hash that was committed to in the address. But all of this is done in zero knowledge, so we're unlike Bitcoin, we're not revealing this script to the network. Okay, so all of this kind of remains hidden. This example here is particularly interesting. This is a multi-sig script on ETHDam. Privacy coins have typically had an issue with multi-sig. They can do basic transfers pretty easy, but then you start trying to say, well, how do I do multi-sig? And it starts to become a mess. Like some of them have to do like a Schnorr aggregate signature where you have many rounds of communication and the user experience really just breaks down. But with this, because we can create any script that we want, we're kind of back to multi-sig, kind of the way we're all familiar with it, which is pretty great. But can we do more? So when the script executes, we have these two parameters, private and public. We pass into the script as it's executing these arguments here that allow the script to inspect all the private and public data that's part of the transaction, and then make decisions whether to lock or remain locked based on what this data is. And the private data and public data, it contains all the data, not just about the current input being spent, but all the other inputs and outputs on the transaction. So you have basically full covenants that you can do things like this script is pretty much saying like these coins can't be spent unless they're being sent to this particular address. Okay, so we're just putting a restriction on where the coins can be spent. We can one-up that and take it just a little bit further, and we can make what I would call a recursive script. And now this isn't a recursive function because we can put a recursive function just inside here and just iterate over that as much as we want. A recursive script in this context is every time what this is doing is it's saying in order to spend from this script, it has to go back into the exact same script. Okay, can't go to any other script. So you can think of this as sort of every spend of this UTXO is an iteration of a loop essentially. And in every iteration, I can decide which one of these methods I want to call. So this is starting to look very much like a smart contract where we have methods, it's deployed on the network, and we have methods that we can call. And from there, we can just add state to it. So outputs can have state attached to it. They can read the state, they can mutate it, they can manipulate it. You can, in this little example, I have a method called increment counter, which just reads the state and increments an integer. So basically, we have all the components of a smart contract. We have a script that's deployed on the network that has methods associated with it, that has state associated with it, that you can make repeated calls to it. You can manipulate that state. Contracts can interact with other contracts. They can make function calls on other contracts. Other contracts can call their functions or read their state. So we've got everything. And all the components of a smart contract, but all in zero knowledge and all without revealing any of this information to the network. So when we look at a transaction over the wire, this is really all you see. And there's really no identifying information here. So you don't know, is this a basic transfer? Is this a smart contract? Was this a token, right? We could be sending tokens around the network instead of, ETHDam coins. We don't know because it all just looks like an encrypted blob to anyone looking at this. Another nice thing we see, there's a fee attached to this. This fee is just similar to Bitcoin, it's just there to prevent spam. It's not a gas fee, so we don't have a need for gas because all these transactions are going to verify in constant time. So it doesn't matter if this is a basic transfer or whether it's the world's most complex smart contract, that they all take the same amount of time to verify. And because they're taking the same amount of time to verify, we don't have to do what like Ethereum does and start charging fees per opcode and things like this, where the more complex your smart contract is, the bigger the fees you have to pay. Okay, it's all constant. Okay, so there's more to Ilium than this, but that's just kind of an overview of how we sort of achieve this zero knowledge property and build a completely private blockchain. So what do we have? Extensibility, yes, pretty much anything that you could do on a traditional smart contracting platform, you could do in this model. Privacy, right? All transactions look the same. You can't tell one from another. There's no private data being leaked on any of these transactions. Fast, I did mention, briefly mentioned Avalanche. Doesn't have any relation to the Avalanche network, the AVAX, who's the sponsor of this event, except that I do use a custom version of the consensus algorithm that I wrote with some tweaks to it to address some of the kind of perceived, maybe some security trade-offs that they make. So I could elaborate more on that later if you ask me about it. And then scalability, haven't really done anything new with scalability, but a lot of the cryptographic primitives that are in place could potentially be used as a foundation for things like proofs of consensus and succinct blockchain, because all the tools to do that are still there. So we have an alpha network live right now. If you wanted to test it out, there's a faucet where you can get some coins. Hoping to move to a more formal test net middle of this year or so. And depending on how all of that goes, maybe mainnet launch later this year, early next year. Okay, thank you.
Awesome. Thank you so much, Chris. And now if we can have the lights up so we can see everyone's beautiful faces. Lovely. Do we have any questions? Closer.
What cryptographic backend do you use for zero knowledge?
Nova.
Nova?
Yeah.
Oh, very cool.
Yeah.
We should talk.
Yeah, it's not, I should say Lurk is using Nova, and so I'm using Lurk, so by extension it's Nova. Other than kind of, following the development and the pull requests and everything, it's, I'm not like super deep in my knowledge of how it works, but yeah, but I can talk about it, yeah.
Yeah, what's the catch? No solidity compiler probably.
Yeah, yeah. I mean, someone could probably make a compiler that could compile Solidity into this. It's just the model's a little bit different. So that I don't know if it would be like, it's not going to be like a one-to-one port of a contract directly over to this, but yeah.
Awesome. Do we have any other questions? No? Awesome. Well, thank you again so much. right, awesome. Thank you for being here. And now we have Daniel.
Hi, everyone. I'll be filling in for Ventali today. I think she was on the program. I'm here with the LIDA Foundation, and we'll be talking about Valida, our zero-knowledge virtual machine, and how we're using it to push the performance and usability of zero-knowledge proofs. Is this the, how do I click? Uh-oh. Is this the clicker? Am I doing something wrong?
It should be, but it's not plugged in.
Oh, yes, of course.
Just 2 seconds. Always the third.
It's a spin manifold. Keyboard set up. There we go. Great. So yeah, here's an outline. We'll be talking about virtual machines in general, some of the different types, some of the limitations with some of the other virtual machines on the market today, as well as what we've done at Valida to create the fastest VM out there, and a little bit about the future. So the motivating question is, how do I prove succinctly and in zero knowledge that a given program was executed and that the gave the correct result? So importantly, this is supposed to be a universal thing, right? A zero-knowledge virtual machine will be a zero-knowledge circuit that can prove the execution of an arbitrary computer program specified in some given language. The key properties we need are succinctness and zero knowledge. Succinctness, proofs are not too long, can be said differently in the context of a virtual machine, that it should be much faster to verify the proof than it is to run the actual computation. Zero knowledge, this is the key property for privacy, right? The proof should reveal no information on the internal states of the machine in the course of running the computation. So this would include any private inputs such as secret keys or transaction amounts, account addresses, something like that, that you would use inside of the machine. These are wonderful pieces of cryptography that are really pushing the space forward. However, right now, zero knowledge has these two major problems. One is that it's a technical subject. A lot of the tooling, even that's supposed to be developer friendly, still has a pretty steep learning curve, as well as the proofs themselves are large and, they're not large. That's the key property. The proofs take a lot of time, space, and energy to create. So even though they're really fast to verify, the cost is, when making the proof yourself, it takes a lot of time to do so, right? So we hope one day that we could do something like generating these proofs, totally client-side on your phone or something. But this is a challenging thing to do. Right now, this tooling is rather slow. So here is a wall of text on some of the different high-level approaches to creating these virtual machines. So maybe ignoring some of the details on the slides here, but the big idea here is like, what do we mean to specify a computer program, right? Everything from C to Magic the Gathering is Turing complete, so the property of being universal isn't very specific. And there's sort of two ends of the spectrum here. One would be to have a domain-specific language. A well-known example of a project that does this is Cairo, and this can be thought of as a sequence of macros that lets you create zero-knowledge circuits directly. This is good for sort of fine-tuning of performance, but is bad for the difficulty of use, as well as it's a little bit harder to reason about the mathematical correctness. So this is a common dichotomy in programming outside of the zero-knowledge context, where low-level languages let you get performance really correct, and high-level languages let you specify the correctness of execution at a level that's easier to reason about. And the approach we take with Valida is this third one. So here we define a virtual machine with an instruction set architecture, like an actual processor has. Ours is extremely simplified, so only a very small number of instructions. And we compile from high-level languages to this, and then this is what we actually implement in zero knowledge, the state transitions, memory loading, and stuff for the virtual machine itself. And we hope that ZKVM will be the dominant way in which developers will use zero knowledge, and this will help with increasing productivity as well as avoiding security flaws. Zero knowledge is a complex subject. There's a lot of difficult cryptography involved, and we don't want everybody who's building a privacy application to have to start from scratch and do this. So with the ZKVM, you can write your code in a language of your choice, compile it, run it, and prove it in zero knowledge. And so you can get all the benefits, both the privacy and the scalability coming from zero knowledge without needing to do the cryptography yourself. So this is a crowded space right now. There have been a lot of VMs just this year. However, we think that many of them have some real problems that we're trying to solve. As I mentioned on the previous slide, a lot of these use a domain-specific language that has a steep learning curve for developers, both in terms of the language itself and sometimes things like you have to have absolute bounds on number of repetitions in a loop. Memory is structured in an unfamiliar way. So it's not just a superficial difference in the language, it's actually a really unfamiliar programming paradigm. Also, several of the other virtual machines out there have claim to be open source, but then have closed source components, for example, proof aggregation or generating the constraints for the virtual machine itself. Another thing that is really important is to have built-ins. You can think of like the Ethereum precompiles, but in the ZK setting, for cryptography operations like signatures or hashes, as well as blockchain operations like EVM transactions. And finally, the sort of most important thing that we're trying to solve is that many of the virtual machines that exist today are still not nearly performant enough to be able to be used at a large scale. And some of the reasons for this are the design of the machine itself is not tuned for optimum performance in zero-knowledge circuits, but rather for familiarity or using a instruction set that exists in ordinary electronic computers. Finally, we want to make sure everything is very extensible so that there's been a new crypto paper on this subject like every 2 weeks that changes everything. So we want to be able to keep pace with these advances. So extensible, performant, and developer friendly. Here's a kind of schematic of how we went about this. So we start with the cryptography, choosing a proving system that has the optimum set of trade-offs. So there's generally a trade-off between proof systems that have really small proofs and proof systems that have really fast provers. And there are some tricks for combining those. Then the virtual machine itself is, we call it ZK-friendly instruction set architecture. So we take a really small, really simplified model of a computer processor, and we compile everything to that. So an important part of this process is step 3, to create good compiling tools that let you take a program written in a high-level language like Rust, high-level in this context, and have something that can be proved in our system. So this kind of lets us have our cake and eat it too, with the choice on one of the previous slides that we use a instruction set that's tailored for zero knowledge to give us really good performance, but then we also create the necessary tools so that developers don't need to use anything unfamiliar to work with it. Finally, these last 2 steps are a little bit more forward-looking, but we want to have use hardware acceleration ranging from GPUs to maybe FPGAs or ASICs one day to really boost the performance as much as possible. And then finally, we want to use formal verification for all the key steps in the process. the idea is that this zero-knowledge virtual machine might one day be the main engine that powers some large-scale zero-knowledge roll-up or blockchain that could potentially have a whole lot of money on it. So we want to make sure that every key cryptographic piece of it is not just audited, but formally verified in the sense of formal theorem prover like Lean. Okay, I'll say a little bit about the design, some of the choices we made to get the performance that we have. So we can think of this virtual machine as sitting in between a prover and a compiler. So the compiler takes high-level language, spits out something that our virtual machine understands, and then the virtual machine creates a set of constraints, some mathematical model of computation that's far away from how you normally think about it, and this is what's actually proved cryptographically. So a key part here is to make sure that we use the most efficient instructions possible. For example, we have special instructions to do finite field arithmetic in our instruction set, and we remove most of the registers to simplify the CPU itself. And then on the compiler side, we have to replace calls to instructions that we don't have with sequences of equivalent ones that we do. So at a high level, we divide our system up into a set of chips. So we have the main processor, one for memory, one for binary arithmetic, as well as a couple more specialized ones here. And then the cryptography underlying it is Starks, and specifically Starks over a small 31-bit field. This is a schematic of what I just said. So right here's what we're proving. We separate read-only memory for the program. It's a Harvard architecture. You can't edit your own code. A big RAM and input-output. And these communicate through a series of buses with this set of chips, each of which is a separate zero-knowledge circuit. So we do not have any general registers. The only registers we have hold the program counter and the frame pointer. So these tell us where the instruction that we're about to execute is, as well as where the local variables are stored. We can address RAM both in relative and absolute modes. Can't address ROM at all. So this is a very different construction than you usually have with an electronic computer. And that's because there's no notion of fast versus slow memory in zero knowledge. Right? In an actual physical circuit, then you want to avoid addressing main memory as much as possible, use caches, use registers, because they're orders of magnitude faster. And that concept just doesn't translate here. So the notions of processor that work in the general electronic model are not the right ones to use for zero knowledge. Yes, a little more about this. We don't have a stack pointer. So our stack frames are constant size, and anything that doesn't fit in that just go onto the heap, which again is really no more expensive to use than anywhere else. So when using the VM, you'll first run it through the execution engine. So this is the actual virtualization. You take your software, you run it, and you record an execution trace, so all the intermediate values used to generate the ultimate value of the computation. And then you prove that you have this execution trace. This is the cryptographic part. And then this proof is succinct and can be verified cheaply later on by anyone, for example, on-chain. One key thing that makes our system fast is that we use this baby bear field. It's a 31-bit field, and because it's very close to a power of 2, the arithmetic in this field can be done really quickly in actual physical hardware. You need to constantly be reducing mod p, and doing that is easy because p is very close to a power of 2. However, this field is too small for cryptographic security, so the actual cryptographic challenges come from an extension field. And then the system that we use to commit to polynomials, the core cryptographic primitive is Fry. This is what's used in all Stark systems and is really by far the fastest polynomial commitment scheme out there today. So when our execution trace is separated into one for each chip, each of these is a separate zero-knowledge circuit. And then we later prove the correct execution for each chip. And then later on, we prove that the chips have compatible views with one another so that, for example, the processor chip and the memory chip have the same view of all of the loads and stores. Then to actually do this cryptographically, we represent these vectors as polynomials using interpolation, commit to these polynomials, and again, with this, we do what's called a permutation argument for this compatibility check. So given all these single variable polynomials, one representing each sort of column, each variable over time, we combine them in a constraint equation to get a single polynomial, and then we show that it vanishes on the correct domain. So this is the setup that is used sort of throughout the zero-knowledge literature. So maybe let me not say a whole lot more about that. One key fact is that we require constraints to have degree at most 3 because constraint degree is a large driver of cost. Again, we're using this baby bear field. We might one day be able to use the Mersenne prime field using some recent advances in the Stark literature. This field has even faster arithmetic because it's literally just 1 off from a power of 2. A main part of our project is the compiler as well. So we can compile from LLVM to our specialized instruction set. Here's a schematic on what that compiler pipeline might look like. But again, right, we use ordinary programming languages, ordinary compilers to generate the LLVM intermediate representation. This is something you can do with the compiler that's already on your machine for your language of choice. And then we have a series of further optimizations before we get the thing that we actually prove. So here's our GitHub. You can download it now. You can write your own chips and have them generated at compile time to get a machine that has, the exact operations that you want optimized. And everything is fully open. We welcome outside contributions. We have an Apache MIT license. And I think I won't have time for this demo. Here's a little mock-up of what the developer interface might look like. So something like GitHub Pro, but in zero knowledge. We have an early access program, so if you'd like to build with Valida right now, all of our code is on GitHub, and we would absolutely love to talk to you to support integration. We're hiring across, as everyone is, cryptography compiler engineers, as well as product people, and not necessarily employee open source contributors. Here's our contacts. I'm Tesseract. Our founder is Ventali. We'd all be really happy to hear from you.
Awesome, thank you so much. We can leave this one up, and if we can have the lights up. And do we have any questions? We're good? All right, well, thank you again, Dan. We really, really appreciated it.
Thank you.
And so that is the end of the programming at this stage. You can still head downstairs for the conversation about regulation and innovation, and then after that, there will be a debate about scaling. So yeah, thanks so much for being here, and we'll see you around ETHDam.